The sine graph is a very simple math concept that is very easy to understand if you follow these essential steps that I'm going to teach you in this video. Firstly, before even attempting the sine graph at a grade 12 advanced functions math level using radians, I'm going to start off by showing a simple review on the easy and basic points of a sine graph in degrees. As you have learned prior to this lesson, these points are what you should previously know. As you will see, the sine graph in radians looks exactly the same as it does in degrees. This is why you should not be discouraged. Firstly, I'm going to write out the main points so I can show you guys how to choose the appropriate scale so we can fit it onto a graph when we are ready to do so. It is important to note here that 5 points is considered one full cycle. Now you will see me convert the points in degrees into radians. Just as a basic recap about radians, the relationship between degrees and radians is as follows. 360 degrees is equivalent to 2 pi rad. Therefore, when converting these degrees into radians, we simply divide each side by the degrees. Therefore, the degrees will cancel out and you are just left with the radians. This procedure is applied to each of the degrees to find its equivalent value in radians. As you can see, each degree value was multiplied by pi and divided by 180 degrees. The degrees cancel out and you are left with 90 times pi divided by 180 and you are left with the radian value. Now we are fully ready to graph these points. It is important to notice that since the y value will go up to 1 and all the way down to -1, this will help us make our scale because we can easily just go up by half. Now that we have a full sine graph in radians, we are almost done. But we can't forget about the properties of the graph because that will help us as we advance into transitions and moving the sine graph around. Most of the properties are very easy to visually see. The properties that we're going to cover are the maximum value, the minimum value, amplitude, period, domain, and range. As you can visually see on our graph, the maximum value, meaning the highest point that this graph goes up to, is +1. And likewise, the lowest point, if you look at the graph, that the graph reaches is -1. That is the minimum value. So our maximum value is 1 and our minimum value is -1. The amplitude is not as easy to visually see as the maximum and minimum points were. So we have a very simple mathematical equation to help find it. Max minus min divided by 2 will equal the amplitude. And we previously just found the max and min, therefore it is just a matter of plugging these values in and dividing them by 2. Then comes the period, which is represented by the variable t. This period for this graph is 2 pi. That means that this graph goes up to 2 pi on the x-axis. If you visually see on the graph that the x value last point is 2 pi, that is your period. The domain is x is an element of reals. This means that x values can be absolutely any number. However, the range has some limitations. If you look at the graph, you notice that the range only goes through -1 and 1. This means that the range is y is an element of reals, but has to be between -1 and 1. Now here's a comparison between the graph in degrees and in radians to show you that they are the exact same graph, they just use a different form of numbers instead of degrees. Therefore, you cannot be discouraged by radians. Knowing about the properties of the graph will help when getting started with basic sine graph transitions. Take a look at this graph for example. Do you notice anything different from the original sine graph that we have just plotted? Well, if you are thinking that the max and min points are now 2 and -2 instead of 1 and -1 as they were in the original sine graph, then you are correct. All this means is that this graph's amplitude is now changed. If you remember the equation that we used earlier, it will definitely help you find the equation for this graph. Another thing that I want you guys to learn and notice is that if there is a change in amplitude, this also means that it is considered a vertical stretch. However, there could also be a vertical compression, just depends on whether it is a whole number or a fraction. The result of the amplitude should equal 2, and this will also tell us that the equation is y equals 2 sine x. Here are a list of practice problems with answers below, which I highly encourage you to do if you feel very confident based off this mini math lesson on the sine graph.